Okay, welcome to the problem solving questions for this unit. Let's get started with the first one. We're evaluating f of x times g of x. So we're evaluating f of x, so it's going to be 3x squared sine of x. And then, so since we have it looks like we're going to have to use integration by parts, but since we have this like algebraic part here, we might be able to use the tabular method. So I'm going to draw a little table here of u, dv, and the signs. So I'll put 3x squared here, sine of x here, and then just fill this in until it goes to 0. And then let's fill in the integrals as well. And then plus, minus. And then let's go 1 over 1 down. So writing our answer out, we have negative 3x squared cosine of x plus 6x sine of x plus 6 cosine of x plus c. So that is part 1. And we'll now move on to part 2. So if you try to do part 2 on your own and you couldn't get it, that's totally okay, because part 2 is incredibly challenging. It's probably one of the hardest problems I've ever asked. So don't beat yourself up if you couldn't get it. Okay, so part 2, we're asked for the inverse of sine of x. So the inverse of sine of x, which is that, plus f of h of x, so sine of the natural log of x. Okay. So now let's put this into two different integrals. So I'll use orange for the first one. And then after that we'll solve the second integral, and then we'll add those two together. So for this first one, this is the easier of the two integrals. We're gonna say, even though it doesn't look like it, this is one of the problems where you can use integration by parts. So we're gonna let u is equal to the inverse sine of x, and then du therefore is gonna be 1 over the square root of 1 minus x squared dx, and then dv is gonna be, this is all that's left, so dv is dx, and then v is gonna be x. So then, using our ultraviolet voodoo formula, we're going to say that this is equal to uv, so x times the inverse sine of x minus the integral of v du minus the integral of x over. And now how do we evaluate this? Well, we're going to use the u substitution with saying u is equal to 1 minus x squared, and then du is negative 2x dx. So that's going to give me, I'm just going to do this in a separate color. I'm just going to move it over to the side. So the integral of x over square root of 1 minus x squared. Right, so then I want to replace x dx. So then I'm going to bring the negative 2 down there. That's going to give me negative 1/2 du equals x dx. So I'm going to replace this x dx with negative 1/2 du, and then I'm going to get negative 1/2 times 1 over square root of u du, which is the integral of negative 1/2 times integral of u to the negative 1/2, which is negative 1/2 times 2u to the positive 1/2, which is negative u to the 1/2. And then since u up here we said u is 1 minus x squared, this is equal to negative square root of 1 minus x squared. Now that we did that, we can move back into our original problem. We have minus negative, so it's going to be a positive square root of 1 minus x squared. Okay, that was part 1. This is half of the answer. And now let's look at the second part, the sine of the natural log of x. Let's do that in this yellow color. Sine of the natural log of x. Alright, this is the slightly harder part. We're gonna start with u substitution, and we're gonna say u is equal to the natural log of x. Du therefore is 1 over x dx. And then here's the thing I'm gonna do. Since u is equal to the natural log of x, if I solve this for x, I'm gonna get x equals e to the u. Right? So I can take this and replace it in for x here. So du is 1 over e to the u dx, and then dx equals e to the u du. So I'll plug that into there. So this is going to be the integral of e to the u sine of u du. And then to figure this integral out, if you remember, this is integration by parts, where we have a trig times an exponential, or an e to the u sort of thing. So this is going to be where we're going to have to do it twice, and then like treat it like a variable, that sort of problem. So let's do that. Let's start with, okay, so since we're gonna be doing integration by parts and we're gonna have u and v, I'm just gonna write this as x, just to make it easier. We don't get mixed up with all the different u's that are going on. So u is gonna be sine of x, du is cosine of x dx, dv is e to the x dx, and v is e to the x. So this is equal to uv, so e to the x sine of x, minus the integral of v du, so minus e to the x cosine of x dx. And then the cosine part is going to be, we're going to do another integration by parts, where u is cosine, du is negative sine, dv is e to the x, and v is e to the x, e to the x dx here. And then this is going to be uv, so e to the x cosine of x, minus the integral of v du, minus the integral of v du, so e to the x negative sine of x. And then we're going to take this whole thing, plug it back in for that, and we're going to get minus e to the x cosine of x minus the integral, I'm going to erase because space reasons, minus the integral of e to the x negative sine of x. And then if I distribute the parentheses and stuff to make it look nicer, I'm going to get e to the x sine of x minus e to the x cosine of x, and this negative and this negative are going to cancel, so I'm going to get a minus e to the x sine of x dx. Remember, all this is equal to the integral of e to the x sine of x. So then I add it over there, divide by 2, and then I get over 2 plus c. So now what I can do is I have that. And then remember at the very beginning, we did this initial u sub, where u is equal to the natural log of x. Now we're going to undo that, and then replace all of these x's with natural logs. So the integral of the sine of the natural log of x is e to the natural log of x, sine of natural log of x, minus e to the natural log of x, cosine of the natural log of x, over 2 plus c. And then since e to the natural log of x is just x, because e to the x and the natural log of x are opposites, this is x sine ln x minus x cosine ln x over 2 plus c. And then remember, this is part 2 of our integral. Remember, we had 2 parts. This is part 2. And then, or is it up here? We had part 1. So remember how in the very beginning we had these 2 things here. We had the sine and the natural log. So in our final answer, since we solved for both of these individually, now we need to put them together. And then we're going to have the integral of the inverse sine of x plus, the sine of the natural log of x dx equals, okay, let's see if I can fit this under one line. X inverse sine of x, this is the first part, plus square root of 1 minus x squared, plus, and then the second part, x sine of ln x minus x cosine ln x, all of that over 2 plus c. Okay, so this is part 1, this is part 2, put both parts together, and now we have our final answer for question 1 part 2. Like I said, that was a hard one. Don't stress if you didn't get it. The rest of the questions aren't going to be that hard. So yeah, we finished question 1. Now let's go on to question 2. Okay, after that huge mess of a problem, let's move on to question 2, which I can promise you is easier. So we're given 3 indefinite integrals, and we're going to find out whether they converge or diverge. If it diverges, we'll find out if it goes to positive or negative infinity, and if it converges, what does it converge to? Okay, so let's start off with part A. So we're given the integral from 0 to infinity of this, and then I'm going to rewrite this as, since our upper bound is going to infinity, I'll say the limit as b goes to infinity, from 0 to b. We're just taking the limit of the upper bound as it goes to infinity. And then, so before we worry about the bounds, we need to just evaluate the integral as like a regular integral, I guess. I don't know. So this is going to be an integration by parts. I'm just going to quickly like breeze through it, because that's not the main focus of the problem. I'm choosing u as 1 plus 2x because that's the algebraic part of the problem. You should know that the integral of e to the negative x is negative e to the negative x. That'll make it easier. This is equal to uv. So v du. I can bring out the negative 2 out, so I can make the 2 negatives will make a positive, and there'll be a 2 there. Like I said, the integral of e to the negative x is negative e to the negative x. So negative 2e to the negative x. I don't need the dx anymore. So instead we're going to have plus c. And then if you want, you can simplify this a bit more and get negative e to the negative x times 3 plus 2x. And then so now that we got this, I'm going to take this and plug it in for this. So it's going to be, still have that, and then this stuff, so negative e to the negative. And then this is being evaluated from 0 to b, because the top bound is what's going to infinity. And then I'm just going to plug in b in for these. And I'm going to take the e to the negative x and bring it to the bottom. That's usually a good strategy, not always, but here it's going to work. And we're going to get negative e to the positive b plus 3. And the plus 3 is because if you plug in 0 into here, you're going to get 3 times negative 1. And then the negative and this negative would make a positive. And then this is and we're taking the limit as b goes to infinity. And we take the limit as b goes to infinity for this. We're going to have to use L'Hopital's rule. So the limit as b goes to infinity of 3 plus 2b over e to the negative e to the b. I'm going to have to use L'Hopital's rule to evaluate this. And that's going to give me 2 over negative e to the b. If I plug that in, I'm going to get 2 over infinity, or 0. So this comes out to be 0 plus 3, or 3. So my integral converges, and it converges to 3. Okay, I'm just going to erase this, and we'll move on to part 2. Okay, part 2. And we notice it's the same like numbers as before. It's just different bounds. So this time, instead of using b, I'm going to use a. It's just a matter of personal preference as to which one you use. So it's integral from a to 0 of 1 plus 2x e to the negative x. And then, so if we do the same integration we did before, we'd get negative e to the negative x times 3 plus 2x from a to 0. And this time when I plug in a, I'm not going to bring the e to the x to the bottom. You'll see why in a second. This is going to be, again, if we plug in 0, you're going to get negative 3 minus, so I'm going to get negative e to the negative a times 3 plus 2a. And let's think about this. If I plug in negative infinity, this is going to go to negative infinity. This e to the negative a part, the negative and the negative are going to cancel. Right? This negative and this negative are going to cancel. So this is going to be a positive infinity. And then this is going to be negative. So the negative and this negative are going to cancel. And we're going to get infinity times infinity, which is infinity. So this limit is equal to infinity. So it's negative 3 minus infinity, which is negative infinity. So the integral diverges, and it diverges to negative infinity. Okay, now let's look at the final part of the question. Alright, part C. So you notice that the denominator for 1 over 10 plus 2x, the denominator equals 0 at x equals negative 5, right? So that's our like band value. So what we can say is that we're going to take the limit as a approaches 5 or negative 5 from the right, because that's like the value that we want to find out what's happening, of the integral of 1 over 10 plus 2x, and the bounds are a and 1, right? And it's from the right because like the whole function is on the right of negative 5 that we're dealing with. And then so let's find real quick, let's find the integral of 1 over 10 plus 2x. This is just a simple u substitution. You do that, you're going to get 1 half ln 10 plus 2x plus c. And then if I take that and plug it back into here, I'm going to get 1 half ln 10 plus 2x from our bounds are a and 1. So if I plug in 1, I'm going to get the natural log of 12 over 2 minus, and then let's look at the a part. Okay, let's see what happens if I plug in -5. This is going to go to 0. And if you think about what happens to the natural log function as it goes to 0, well, it goes to -infinity. So that means this whole limit is going to -infinity. This is the natural log of 12 over 2 minus -infinity, so plus infinity. That's going to go to infinity. So this limit also diverges, but this time it diverges to positive infinity instead. Okay, so that was question 2, and now let's look at question 3, the last question. Okay, question 3. So we have, looks like we have 3 partial fraction questions here. Start with the first one. We're evaluating this integral, and then I can write this as 4 over, and then for the bottom I'm going to split it up by factoring it into x minus 2, and then x plus 7. And this is going to be, remember, this is going to be some number a over x minus 2 plus some number b over x plus 7. I should put dx here as well. And then if you know the really quick trick on how to do this, it shouldn't be more than a small thing. So for a, 2 is what makes the denominator poor here, right? It's what makes it 0. So I'm going to cover up the x minus 2 over here, and then plug in 2 for the rest of the equation. So it's going to be 4 over 2 plus 7, so 4 over 9, and that's going to be my value of a. And then for b, -7 is what makes this 0. So I'm going to cover up the -7 and then plug in -7 into the rest. It's going to be 4 over -7 minus 2, 4 over -9, or -4 over 9. That's my value for b. And then this means I have the integral of, I'm going to plug in a and b back in, since I know their values now. I'm going to have 4 over 9 times 1 over x minus 2 minus, because b is negative, 4 over 9 times 1 over x plus 7. And these are both, since it's 1 over something, it's just going to be the natural log of that thing. Add the plus c. You can factor the 4 over 9 out if you want, but I'm just going to leave it. And we are done with part 1. And then look at part 2. How do you think we're going to approach this kind of question? So if you said partial fractions because it looks like a partial fraction, think one more time, because this is actually a u substitution question in disguise. It's one of those tricky ones I talked about, where if it looks like a partial fraction question, it looks like you're gonna have to factor the denominator and then do that. But you can just say, okay, let u equal x squared plus 4x plus 3. Then du would equal 2x plus 4 dx. And then if I multiply both sides by 1.5, I'll get 3 over 2 du is equal to 3x plus 6 dx. I'd plug this back into there, and then I'd solve it like I would a normal problem, like a normal integral. So that's this little thing. I want to see if you noticed that. So part C, we can't use that same method this time, and we're gonna have to, since the exponent on the top is greater than the exponent on the bottom, that means first we're gonna have the extra step of doing long division. So let's do that. We're going to have x squared plus x minus 2 divided by, oh, I shouldn't have done that. Okay, it's fine. X to the fourth plus x cubed plus x squared plus 0x plus 1. Don't forget the 0x. And then so x goes in x squared times. So x squared plus x cubed minus 2x squared. And then 3x squared. And then this goes in 3 times. So 3x squared plus 3x minus 6. It's going to be negative 3x and then plus 7. So I can rewrite the thing they gave me in part C. I can rewrite this as integral of, so I have the x squared plus 3, and then I also have this guy over this guy. So 7 minus 3x over, so now I have this, which I can easily integrate by using the normal methods, and then I have this, which I can integrate by using partial fractions. So let's leave the polynomial aside for now, and let's just focus on this guy. And I'm going to take this, I'm going to rewrite it as negative of 3x minus 7. And we're just going to ignore this guy like completely for now, and we'll just deal with it at the very end. So again, this is going to be a over, if I factor the bottom, I'm going to get x minus 1 and then x plus 2. So I'll have a over x minus 1 plus b over x plus 2. If you did the same method I just said, since x equals 1 is the problem here, I'm going to plug in 1 into the rest. So I'd say that'd be 3. So for a, it's going to be 3 times 1 over 1 plus 2, which is negative 4/3. And if I did the same for b, I'd get b is equal to 13/3. So this is the negative integral of negative 4/3 times 1 over x minus 1 plus 13/3 times 1 over x plus 2, and then integrate this, which is going to get me negative, and the negative are going to make a positive, so 4/3 natural log of x minus 1, and then so make minus 13 over thirds natural log of x plus 2 plus c. And so this is the hard part. And if you remember, we had that little x squared plus 3 left over. Well, I can just integrate this real quick. I'll get x cubed over 3 plus 3x. So putting both parts together, I'm going to get x cubed over 3 plus 3x plus, I'm going to be a fancy person now, and I'm going to use my snipping tool. And with that, we have our answer. Ta-da! This is, so if you just recount what we did, we first did long division to split the polynomial into something that we could use partial fractions with. So this is the part of partial fractions, and this is the remainder, the polynomial part. And so we just put those two together, and we have our final answer. So that was the problem solving video for this unit, where we focused on some of the BC topics. This was a definitely challenging video, but hopefully you found it helpful and clarified some of your doubts, and I will see you in the next one. Goodbye for now.